So good day everyone. My name is Jandale David B. And I will be discussing my Activity 5 Pulse Amplitude Modulation Circuit. Before we proceed to the circuit, what is Pulse Amplitude Modulation? Pulse Amplitude Modulation, or PAM, it is a form of signal modulation where the message information is encoded in the amplitude of a series of signal pulses. And it is an analog pulse modulation scheme in which the amplitudes of a train of, of carrier pulses are varied according to the sample value of the message signal. So, pulse amplitude modulation circuit. In this circuit, it consists of Wien bridge oscillator, this one, and the square wave generator, this one. So this is the sine wave generator that serves as the signal, and the square wave generator serves as the carrier signal. So this BJT, it is the palm modulator. So oscillator is a circuit which produces a continuous, repeated, alternating waveform without any input. Basically, convert unidirectional current flow from a DC source into an alternating waveform which is of the desired frequency as decided by its circuit components. So this is my Wien bridge oscillator. I choose this Wien bridge oscillator because it is much easier to build. So here, this is the high pass filter, this is the low pass filter. So the Wien bridge oscillator, it uses 741 op amp or operational amplifier. The series of R2 and C2 serve as the high pass filter. The parallel R1 and C1 serve as the low pass filter. In this oscillator, R1 is equal to R2 and C1 is equal to C2. These serve as the signal. So to determine the frequency output, the formula is frequency is equals to 1 over 2 pi RC, or wherein R is the resistor and C is the capacitor. So to determine the resistance in the bridge, R is equals to 1 over 2 pi FC. So F is the frequency. So this one, I wanted a 500 hertz output using a 10 nanofarad capacitor. To solve it, this one is 1 over 2 pi times 500 times 10 raised to 10 times 10 raised to negative 9. So the resistor that I got is 31.83 kilo ohms. But in my case, I use 31 kilo ohms only. So the resistor that is not connected to a capacitor serves as the gain control. So if we go back here, this is the gain control. So it is AV is equals to V out over V in is equals to 1 over R3 over R4 is equals to 3 or more. I use the same value of resistor in R1 and R2, which is 31 kilo ohms. So when I solve it, the value is 15.5k, but I only use 15 kilo ohms. So square wave generator, this is my square wave generator. So this is the pulse generator for this PAM, or pulse amplitude modulation. This serves as the carrier signal for the pulse width. The resistor and the capacitor is the responsible for the frequency of the square wave. So to compute for the frequency output of the square wave generator is frequency is equals to 1 over 2 RC. And for the resistor, so our resistor is equals to 1 over 2 FC. So I wanted to have a 3500 Hz frequency using a 5 nanofarad capacitor. The resistor that is solved using the formula is 28.571 kilo ohms, but I only use 20 kilo ohms. And the condition here is R5 is equals to R6. And to solve R7 is equals to 1.16 R6. So the R7 is equals to 23.2 kilo ohms, but I use only 23 kilo ohms. So the output frequency of my pulse amplitude modulation circuit is above 2000 Hertz. Then this is how I build my pump circuit.